Today what we're going to do, it's a thicker packet, but it's kind of split into two ways. One, learning about the quadratic formula and being able to use it. And then the second one is word problems, which we can use the quadratic formula to solve. So this is section 18.2, so we're continuing on solving quadratic equations using different methods than factoring, basically. So on Monday, we learned about completing the square. And completing the square, we were able to take a quadratic equation, make it a perfect square trinomial, so we could just take the square root of both sides and solve. Well, what someone did, and I can prove this to you, I'll do it after we do our notes, but someone took the generic form of a quadratic and completed the square generically and solved for x. So this is completing the square for any quadratic equation where b is the coefficient in front of your x terms, a is the coefficient in front of your x squared term, and c is the coefficient or the constant in the back, okay? So no matter what, if you can get a quadratic and you can put it in standard form, ax squared plus bx plus c equals 0, then you pull those coefficients, just those numbers in front, and plug them in, and you'll have completed the square and solved the equation. So this worksheet's kind of interesting because we have the exact same quadratics that we're going to solve. On the left, we're going to show the methods that we have used before. On the right, we're going to show using the quadratic formula and how we get the exact same answers. Okay? So let's start with solving x squared plus 6x equals negative 8 by completing the square. So this is a good review of Monday's lesson. So remember, when we complete the square, we have x squared plus 6x hanging out plus blank, and then you can move the constant over, but since the constant's already there, we can leave him there. Do you remember what the next step is to completing the square? What do we need to do?
Take the 6x down, square it.
We have to divide it by 2 first, right? Yeah. So we're going to take the 6 and divide by 2. What do you get?
3.
3, and then we square that, and he goes there and there. So we get 9, right?
Yep.
So remember, the whole idea is, at that point, we've made a perfect square trinomial. What's factors of 9 that add up to 6? 3 and 3, right? So the left side factors to x plus 3, the quantity squared. And remember, that's just a shortcut. Whatever b over 2 is, that's what goes inside there. On the right side, you do the math. What's negative 8 plus 9? It should be positive 1, right? And at that point, guys, we made a perfect square trinomial where we can just take the square root of both sides. So the square root of x plus 3 squared, and then remember we put a plus or minus in front of the 1 when we take its square root. So what happens? The square and the square root are inverse operations, so x plus 3 pops out. On the right-hand side, you can break that down. How does 1 break down? What's the square root of 1? 1. So x plus 3 equals plus or minus 1. So remember, when you break it down and it's a whole number completely, when we move that 3 over, we're going to be able to combine it with that 1. I'll hand back your worksheets here at the end of the lesson, but be careful when you combine it. It's not just going to be plus or minus 2. What we're going to do is we're going to first move him over, so we have negative 3 plus or minus 1 like that. And so then we have two directions we can go. We can have negative 3 plus 1, or we can have negative 3 minus 1. Negative 3 plus 1 gives us negative 2. Negative 3 minus 1 gives us negative 4. So remember, when you get those nice whole numbers like that, that just means the original quadratic was factorable. So say we had moved that 8 over from the beginning, so like x squared plus 6x plus 8. What are factors of 8 that add up to 6? 2 and 4, okay? And we would have been able to factor it, and we would have gotten x plus 2, x plus 4, but when we solved for x, we would have negative 2, negative 4. So again, kind of a good review of Monday's lesson. Make sure the constant's on this side, divide your b value by 2 and square it, add it to both sides. This quadratic always factors to x plus or x minus whatever the b divided by 2 is, so that in case this was 3. And then on the right side, you just do the math. Negative 8 plus 9 is 1. At that point, you have a perfect square equal to a constant. Take the square root of both sides, and you'll solve. Okay? So how can we do this exact same thing using the quadratic formula? Well, the quadratic formula, if you look here, guys, must be in standard form. What's the standard form of a quadratic? Everything has to be to one side equal to 0. So unlike completing the square, we do want that constant over on the other side. So we have x squared plus 6x plus 8 equals 0. So we have to have everything all on one side, like as if you're going to factor it, right? Like that's what we had to do before. Okay. So how are we going to do this? Well, what is technically the coefficient in front of x squared?
X, 1.
1, right? So I'll even put a 1 there, okay? So that's our A. What's the coefficient in front of x?
6.
So that's going to be our B. And what's our constant? 8, okay? So at this point, we know what A, B, and C are, so we have our puzzle pieces. And then x equals negative b plus or minus the square root b squared minus 4ac all over 2a is our puzzle. So we just got to put our pieces into our puzzle and solve, all right? So on our, not this quiz that we're going to take, this won't be on our quiz on Wednesday, but on the last quiz, you'll have this and I'll give it to you, but on the final, you're supposed to have it memorized. Has anybody seen the quadratic formula before? If you've taken an algebra class in high school, they used to sing it to Pop Goes the Weasel to help you remember it. So it's one of those things that every time I do it, I write it generically first. So even though it's right there, I still write it in my problem. Negative b plus or minus the square root, b squared minus 4ac all over 2a. So I like to write it generically over and over and over again so that I can plug things in. Okay? So let's go ahead and start plugging things in. What was our b? 6. And that negative's already there. So it's negative 6 plus or minus the square root of b squared, so we're going to square 6. I'm going to put it in parentheses because if b was negative, we'd have to make sure we put that negative in parentheses. Minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. So you guys see what I'm doing? I'm just using this puzzle, this quadratic formula, and putting my pieces in, all right? At this point, guys, I try to do as much a little bit at a time. So, negative 6 will hang out. And then in my calculator, I don't do the square root yet, but in my calculator, I type that exactly as you see it. So in my calculator, I am typing 6 in parentheses squared minus 4 times 1 times 8. And you guys get 4 there? Okay? So that's under the square root. All over 2 times 1, but that's just 2. Okay? At this point, you're going to break the square root down. Okay? So this happens to be a perfect square. What's the square root of 4? 2. But even if it wasn't a perfect square, say it was like 32, do our little factor trees, make your friend come out, make your friend stay in, that kind of thing. So we're going to break down our square root no matter what. But in this case, the square root of 4 is just 2. So what do we end up having? We end up having negative 6 plus or minus 2 all over 2. Negative 6 plus or minus 2 all over 2. Are you guys okay with that so far? Do you notice every single number is just a nice whole number? There's no roots or anything? So that means we can combine them. So we have two values for x. We're going to have negative 6 plus 2 over 2, and we're going to solve that. And then we're also going to have negative 6 minus 2 over 2, and we'll solve that. And you want to do, like, order of operations, like you want to do the top first. So combine that 6 with that 2 first, then divide by 2. So negative 6 plus 2 is negative 4. And then negative 4 divided by 2 is negative 2. Over here, negative 6 minus 2 is negative 8. Negative 8 divided by 2 is negative 4. So notice we got the exact same answers, which we should. It was the exact same quadratic equation, but this way we didn't have to complete the square. Is there about the same amount of steps? Yeah, if you look at the work on either side, you're doing about the same amount of steps. The nice thing about the quadratic formula, though, is you don't have to really, I know it sounds bad, you don't really have to think about, okay, what do I do next? You're just plugging it in, all right? So let's look at the next one. The next one says, solve 13m equals 2m squared plus 18 by factoring. So this is going way back to chapter 3. In order to factor, what do we need to do with that quadratic equation? In order to factor it, what's the first thing we need to do?
Figure out what I'm
What'd you say? We gotta get the 13 over there first, right? We gotta get everything to 0. So this is gonna be 0 equals 2m squared minus 13m plus 18. So remember, the number one thing in factoring is move everything to one side equal to 0. Then, number 2 is ask yourself, is there a GCF we can take out? No, right? That 13 ruins it. Like 2 and 18 are both divisible by 2, but that 13 isn't. So, number 3, what do we have to do? The AC method, right? So A times C, we got 36. So what are factors of 36 that add up to negative 13? 9 and 4. They're both going to be negative, okay? So this is where you guys are kind of making mistakes. What do I mean by that? If this was just m squared, you could do m plus 9, or m minus 9, m minus 4. But since our a is something other than 1, you can't do that shortcut. You must regroup. So this is going to be 2m squared minus 4m minus 9m plus 18. You have to do this. And this is something that you guys missed on the quiz. We had like a 2x squared there, and you guys would figure out your factors, but then you just go with x plus 3x minus 6 or something like that, okay? If your a is something other than 1, you must have to do the regrouping, okay? So let's look at this. What can you take out of 2m squared and 4m? 2m. So you're left with m minus 2. What can you take out of negative 9m plus 18 so that m minus 2 remains?
9.
And not just a 9, but a negative 9. And remember, you want to get these matching terms, because this is one term and this is one term, but m minus 2 is the GCF. So factor out m minus 2, pull him to the front, and when you pull m minus 2 to the front, what are you left with?
2m minus 9.
You got it. 2m minus 9. What do you do once you get this factored? In order to solve, what are we going to do? Set equals 0. And that's something, again, remember in your quiz, some of you factored that one, but it said solve for x, right? So we're solving. So we're going to set m minus 2 equal to 0, and we're going to set 2m minus 9 equal to 0, and we're going to solve for m. So m is 2, and 2m equals 9, so m equals 9 halves. Does that look right? 9 over 2. So on this one, guys, in real life, if it's factorable, go for factoring. That's seriously my first tip. If you can factor it, factor it. But the quadratic equation is nice because it will get you an answer no matter what. Whether it's factorable or not factorable, you'll be able to do it. Because if this wasn't factorable, you sit here wasting your time trying to figure out factors, and you can't. So let's jump to the quadratic equation. In order to do the quadratic formula, we have to make sure it looks exactly like it did when we did the factoring. We got to move everything to one side equal to 0. So we have 2m squared minus 13m plus 18. That way we can label what is our a, what is our b, what is our c. So what's our a going to be?
2m squared.
Just the 2, okay? And that's something I want to point out. When we use the quadratic formula, guys, you're only using the numbers. No variables should ever be plugged in. And the reason why I point that out is sometimes you'll have an x, so you want to plug x in. No, what's the coefficient of x? 1. And you plug 1 in, all right? So we have a, what's our b?
13.
Negative 13. And what's our c? Positive 18, all right? So again, even though the formula is stated right up here, let's get in the practice of writing it generically. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we have everything labeled. It's a matter of plugging things in. So notice the quadratic formula has a negative b. So it already has a negative, but then what do you notice about our b? It's negative as well. So I'm showing you plugging it in, but if you know what happens when you put a negative with a negative, what do you get?
Positive.
If you want to just put a positive 13 there, you can. But I'm showing it for purposes of, oh, here's the quadratic formula, and this is what we need to plug in. All right, so then we have plus or minus. Again, make sure b is in parentheses, because when we square negative 13, we want to make sure that negative gets turned to a positive. Minus 4 times a, which is 2, times c, which is 18. all over 2a, or 2 times 2. So again, here's my puzzle. Negative b plus or minus the square root of b squared minus 4ac all over 2a, but here are my pieces, 2, negative 13, and 18. So I'm merely plugging them in to where they need to go. So then we'll have x equals negative of a negative 13 is a positive 13 plus or minus, and then in my calculator, guys, I'm just doing what's under the square root. I'm not hitting square root, I'm just typing it. So we have parentheses negative 13 squared minus 4 times 2 times 18. Did you guys get 25 there?
Yes.
Okay. So we have 13 plus or minus the square root of 25 all over 2 times 2, or 4. Again, we know this should be a perfect square because we already know it was factorable, okay? So we know that there should be no root left. What's the square root of 25? 5. So he's going to pop out. So what do we have, guys? We have 13 plus or minus 5 all over 4. So again, since they're all whole numbers with no roots, we're going to split them into 2 answers. X equals 13 plus 5 over 4, and x equals 13 minus the 5 over the 4. And then we'll just do the math. What is 13 plus 5 is 18. 18 over 4 reduces to 9/2. There's your first answer. What's 13 minus 5? 8. What's 8 over 4? 2. So again, notice we got the exact same answers, but we used the quadratic formula. So both of these that we did could be solved either factoring, completing the square, or quadratic formula. But then you get down here to this last one, okay? So this last one's kind of a trick question, because it says solve 7x squared minus 4x minus 2 equals 0 by factoring. And so you sit here, okay, how would we factor it? Can you take a GCF out of that? No? So you're like, okay, what's 7 times 2? Negative 14. What are factors of negative 14 that add up to negative 4? Nothing, okay? So this is not factorable. And if we got this in chapter 13, we'd just be like, it's prime, I can't do anything, I can't solve it. Does that mean it's unsolvable? No, it just means we can't solve it by factoring. So guess what would work? We could do completing the square that we learned on Monday, or we can use the quadratic formula. What's nice about this one, that it's already in standard form. Everything's already moved over in the right order set equal to 0, so we can go ahead and label our A, B, and C. What's our A? 7. What's our B?
4.
Negative 4. And what's our C? Negative 2. Okay? So again, I write the generic x equals negative b plus or minus square root b squared minus 4ac all over 2a. Because the more we can write it, the more it'll get stuck in our head. Alright, again, I have a negative there because that's part of the formula, but then my b is negative as well. So I'm plugging a negative into a negative, so if you want to put a positive 4 there right from the beginning, you can. And then plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 7, times c, which is negative 2. And that's all over 2 times a, or 2 times 7. So I'm just taking my quadratic formula, and I'm plugging in my a, b, and c. And then I'm just kind of cleaning it up. All right, so I have a negative of a negative 4 is a positive 4, plus or minus the square root of, and that's when I put it in my calculator. Can you see that? Clear it out. Negative 4 squared minus 4 times 7 times negative 2. You hit enter, do you guys get 72 there?
Yes.
Over 2 times 7, or 14. All right. So this is technically our answer, but it's not a simplified answer. Like if you put that in my math lab, I'd get mad at you because 72 is not broken down. So I'm going to do a tree diagram, but like sideways off to the side. What are 2 numbers that multiply to be 72? 8 and 9. How does 8 split up? 2 and 4. How does 4 split up? 2 and 2. Is that okay? And then how does 9 split up? 3 and 3. So since it's a square root, what are we looking for? We're looking for pairs. So we have a pair of 3s and a pair of 2s that can come out. And then who has to stay inside? The 2. So x is really equivalent to 4 plus or minus, what can come out? A 3 and a 2. When they come out, what do? They multiply. So what's 3 times 2? 6 root 2 all over what? 14. So now it's kind of getting low. You guys see that okay? But again, my math lab will give you a red X. It'll say, although your answer is correct, it's not completely simplified. What do you notice about 4, 6 root of 2, and 14? They all are divisible by 2, and they all have to be divisible by 2. So go up here real quick. You could not reduce this just because the 4 and 14 were even, because the root does not have an even number in front, okay? All 3 terms have to have that even number. So when you divide each of them by 2, what do you get? 2 plus or minus 3 root 2 all over 7. And you guys just use a quadratic formula on something that you couldn't have solved before this week. So if you're okay with the front page, go ahead and turn over to the back page. So the back of the front page, guys, is just making sure we understand, and we kind of did a crappy job of giving you examples. So all of these happen to have positive numbers under the root, which means they all had 2 answers, okay? So let's talk about what's on the back page here. It's called the discriminant. That's the part that's under the root, okay? In the quadratic formula, the radicand, so this b squared minus 4ac that's under the root, is called the discriminant. And if we know what the discriminant is, whether it's positive, 0, or negative, right off the bat, we know what kind of solutions we're going to have, okay? So, on the first one, if we get a positive number under the root, which we got on all 3 things, we had positive 25, positive 4, positive 72, we'll get 2 positive real solutions. We got negative 2 and negative 4 and so forth. If it was 0 there, and I'll go back, and I know it doesn't make a whole lot of sense because we didn't get to see it, but say this was 0, if that's 0, you lose the plus or minus part, right? Plus or minus 0 is nothing. So you would just have one answer, 4 over 14, and you would just have one solution there. So, if your radicand or discriminant is 0, you just have one solution because you missed that plus or minus root part. And last but not least, guys, we briefly touched on it, but if you had a negative, remember a negative under a square root, it was a non-real solution, and it popped out as an I, and that's all it's saying, is no real solution. Why do we care? Because a lot of times we don't necessarily care what the answer is, we just want to know what kind of answers we want, because we know if it crosses the x-intercepts or not. So if anybody's going on to college algebra, or needs to take college algebra in the future, this is important to know. Are we crossing the x-axis? So if we're equal to 0 and we have 2 answers, we cross the x-axis twice. If we're 0, we're just kind of sitting on the x-axis, so we just sit on it once. And if it's negative, we're floating above it or below it, and we actually don't cross it, okay? So be careful on your homework. Why? Because you'll be in this quadratic formula method, and you'll be plugging stuff in, and then you'll get to the end, and it'll start talking about the discriminant. We don't have to do the quadratic formula. We just have to use the discriminant. So pay attention to your wording, okay? So it says, just use the discriminant to determine the number and type of solutions, not what the solution is, okay? So do you guys agree that this is in standard form? So what would my A be? 1. My B is 2. My C is 1. So the discriminant, guys, is b squared minus 4ac. b squared minus 4ac. That's the part that's under the root. That's the discriminant. So plugging b, we'll have 2 squared minus 4 times a, which is 1, times c, which is 1. And just throw that in the calculator exactly like it looks. What do you guys get when you get square 2 and then you subtract 4 times 1 times 1? Well, we'll get 4 minus 4, or 0. What does that mean? It means if we were really doing the quadratic formula, we'd have negative b plus or minus the square root of 0, but the square root of 0 is nothing. So we don't have a plus or minus part at all. We just have negative b over 2a. So if your discriminant's 0, which this one is, what does that mean? It has one real solution. So on these problems, guys, I think they might just be multiple choice. I think it's 2 real solutions, 1 real solution, or no real solutions. So in this one, the fact that our discriminant was 0, we don't have that plus or minus, we just know we have 1 real solution. let's do the same thing here. I know it kind of looks weird, but what's our A? 3. What's our B if it's missing?
Just B.
Nope. Do we have an X there? So do you guys agree that we have 0 X's? So guess what your B is? 0.
So it can only be a value if
It can only be a number. There's no variable. It can only be a number. So if it's not there, it's just 0, right? And then our constant, our C, is 2. So like say you had 3x squared plus 2x equals 0, your constant would have been 0, okay? So again, we're going to do b squared minus 4ac because we're just using our discriminant. So we're going to do b squared, which is 0 squared, minus 4, which is times a, which is 3, which times c, which is 2. And again, we can just throw that in our calculator, or it's not too hard to do it by hand. This is 0 squared, so that's just 0, minus 4 times 3 is 12, 12 times 2 is 24. So this is negative 24. Do I care that it's 24? No, I care that it's negative. So if this was under the square root, a negative would pop out as an I, a non-real solution. So this matches. It's negative, right? So this matches this, no real solutions. And last but not least, process of elimination, we're going to see something happen here. Our A is 2, our B is negative 7, our C is negative 4. We're going to plug it into our discriminant, b squared minus 4ac. Our b is negative 7, but we got to square all of it to make sure it's in parentheses. Minus 4 times a, which is 2, times c, which is negative 4. Throw that into your calculator, you'll get 49, and then this is 8 times, it's positive 32, so you get 81. So what's that mean? It means we would have 81 under the square root, so that means a positive and negative 9 would pop out of the square root. So again, since this is positive, that's what we care about, positive, it matches the top one where we have 2 real solutions. So we actually can match it to their graphs, all right? So I'm just going to draw them real quick. They're not perfect, okay? But if you have one real solution, guys, what's it look like as far as the graph goes? It's a parabola that's just sitting on the x-axis. So it just sits at one point, okay? If you have one real solution, it's just a parabola that sits on the axis at one point. If you have a parabola that has no real solutions, he's floating, okay? He doesn't actually sit on it. So he could be up here going up, or he could be down here going down. And if you have 2 real solutions, which is usually the case, that means you're crossing twice. And again, I'm just roughly drawing it. You don't have to be always over in the quadrant 1 or whatever. Okay? So a lot of times they just want to know the type of solutions you have. They don't necessarily care about what the solution is. So that's when they say just use that discriminant to get an idea of what type of solutions you have.